One of the things that's really important for us to be able to do is to actually debug our code. Now, there's a lot of different ways we can do debugging. For the most part, you're probably familiar with using IDEs, be it in Eclipse, be it in IntelliJ, something like that for Java code. There are IDEs that exist for C and C++ code as well. When we get into the Linux environment, though, and across multiple platforms, probably the most commonly used debugging environment is GDB. GDB is the GNU debugger, and you can use this on pretty much any Linux distribution and across a lot of different platforms. So what we're going to show in this video is a really quick demonstration of some of the very basic capabilities of GDB. What we're going to show is how we can set breakpoints with GDB, how we can single step through the code, how we can display variables, all of the core things to really get us started with GDB. Now, to begin with, if you do not have GDB installed, you're going to need to install it. Sudo apt-get install GDB, like so, into our Linux environment. Now we can see that on my machine here, GDB is already set up and installed and ready to go. This may not always be the case on the machine you're working on. Most VMs you're going to install this pretty early on. Okay, so now that I have this, what I have is a piece of code over here on the right that has a bug in it. Basically, this code, I want to fix this little line there as well. What it does is it calculates the area of a triangle. The intent is something simple that we can actually be able to step through. We're reading the base, we're reading the height, we're calculating the area, and we're printing out the result to the console. In my make file, we can see that I'm taking here and I've got this -G flag enabled. So the -G flag on the C flags and the linker flags is enabling extra information for the GNU debugger that's going to map this code that is created, in this case GDB demo, back to the raw source code, telling us what lines are and things like that. If you don't have this -G option, you still can use the GNU debugger. It just happens to be a lot harder to do some of the mappings and maybe harder to understand. Okay, so I've got this all set up. What I'm going to do is make my code. So my code built, I've got GDB demo. I can run GDB demo, enter base, enter the height. The area of the triangle is 4. 3 times 3, 9 divided by 2. It should be 4.5. Something's wrong with my code. So as I'm running it, something's broken. I want to figure out why it's broken. So I'm going to go, in this case, to the debugger. So to start this up, you'll notice that over here I have Emacs opened up. And what I have done is, in this particular case, I have turned on showing line numbers here, which is one of these options. I've got absolute line numbers. This is the line numbers for the source file, and we see this is GDB demo. That's useful to have open. And what I'm going to do over here on the left is start GDB, GDB being the name of the program, with that, the name of the program I want to debug. So GDB space name of the program to debug. Not a whole lot of complexity here. It doesn't really show us a whole lot of fancy stuff. It's a textual screen. So what I want to do is I first want to set my code up so that it breaks. So I'm going to type BR to add a breakpoint at main. And what we'll see is it put a breakpoint at line 6. This is where main starts, where that bracket actually is at. Now if I type run, it's going to start running this. We got to line 6. I want to be able to single step through this. If I type N, it's going to go to the next line. I can also type next. So we got there, we're at line 12. We're going to read in, enter a line for the base. We're executing this line right here, number for the base 3. Now, I've read something in. What happens if I would like to see what is in that variable? I can type print base. So print is going to print the value held inside of a variable that I've got. So if I type print base, it's showing me that I have a value of 3 in there. Now I can step to my next line here. I'm going to read in height. Enter the height. I'm going to do 5. I can print out height like so, 5. If I type something in that doesn't exist, for example, H, no symbol H in current context. This is an error indicating that I've tried to print out a variable that doesn't exist. So I've got this. Line 23, we're about to calculate the area. I do a next over that, the area of the triangle. I could actually print out area like so, and we see the area is 7. Ooh, that's not right. 3 times 5, 15 divided by 2, again, should be 7.5. What's wrong? What failed with this calculation of area that I had right here when I executed it? So if I look back at my code, area is base times height. Let's see, base, that's an int. Height, that's an int. 2, that's an int. Oh, I've got an int times an int divided by an int. I'm going to do integer math. Even though I'm assigning this to a double, this is going to give me the wrong value. The correct answer, the correct solution to this is to make this be a division by 2.0 so that it does the multiplication and then does a floating point divide. Basic introductory programming mistake that was made here. Okay, so I save that like so. Now, the code hasn't been updated, so I quit out of this. I remake my code, and then I can restart my debugger. I'm going to put a break on main like so, and start it running again. Breakpoint on main. Next. Enter a number for the base. 5. 7. The area of the triangle is 17.5. 5 times 7, 35 divided by 2. Hey, I think it works right, 17.5. So, it's working well. Now, what I can also do is use some different commands here. So, for example, one of the things I might want is a display command. So I'm going to display the base. I'm going to start running at the beginning again. And what is happening with display is you'll see each time the debugger stops running, it's going to print out what base is. So enter a number for the base. You see it's all a value of 0 right now. If I see in the base 5, now we're going to see that that changes to 5. So if I have a variable that I want to keep track of, is it changing or something like that, I can use a display instead of a print, and it will constantly update it each time we go through and basically do a single step. The other thing I can do here is I can set more advanced breakpoints in my code. So I can do a break, for example, break at GDB demo.cpp colon 23. This is going to break at this source file, this line number, line 23, this calculation right here. So I don't have to just use methods. I can set breakpoints wherever I would like them to be. Now what that allows me to do is I can type continue, and it will continue running until we reach a breakpoint. So if I'm entering my height here, we see that we hit that breakpoint where we're calculating area. I now do my step. I can print area 17.5. If I do continue, we see the program exited out. If I do a run now and start at the beginning, we hit my breakpoint that was at the beginning of main. Now I'm going to do a continue, enter a number for the base. 5, enter a number for the height. 3. You'll notice that we're in a debugger, but we're not stopping. We are continuing running. Now, we did hit our breakpoint here at line 23, right there, so I can see what's going on, and I can see that I've displayed my base and my height. All right, so what do we have here with GDB? We've got the ability to set breakpoints with the BR command, just like you can do in a IDE where you double-click on the line of code. We've got the ability to print out variables, display variables. We can single step with the next command to go to the next line of code. Pretty much all of the fundamental capabilities you have with your IDE for debugging are now capable of being done here at a command line console. It's just a little bit more cryptic as to what you're doing, and you need to keep track of your code versus your debugger. The only other piece that I want to point out As I quit here, inside of our make file, I pointed out that we want this minus G like so. We also want to make sure that we do not have much optimization going on. So the optimization option, this minus O with the compiler, turns off optimization. That will make it much easier for us to do single steps. Okay, so here we are. We have now demonstrated GDB single stepping. Next command, we've demonstrated setting breakpoints. We've demonstrated recompiling the code. We've demonstrated print, and we've demonstrated display. Now you have at least the fundamental basis to being able to use the GNU debugger at the command line to debug source code. That brings this video to a conclusion.